We're going to go ahead and start by converting the following to log form. So 5 to the first power is going to be log base 5 of 125 is equal to 3. Log base 6 of 6 is equal to 1. Log base 9 of 1 is equal to 0. Log, there's a common log, of 0.01 equals negative 3. And then the last one is log to the base 4 of 16 is equal to x. So now we're going to go ahead and write the following as an exponential form. So this is 5 to the power 2 is equal to 25. 2 to the power 3 is equal to 8. 5 to the power negative 1 is equal to 0.2. 3 to the power 1 is 3. And then the last one is 8 to the power 0 is equal to 1. We're going to be talking about logarithmic properties. One property that I do want to just review quickly is a product property for exponents. And we know that if we have the same base, we're going to add the exponents. So the product property for logarithms is almost the same. As long as you have the same base, you can either expand or you can condense logarithms. And this is called the product property. So I'm going to go ahead and explain the first example. The first question you need to ask is, does it have the same base? In this case, it does have the same base. So you can make this into a single logarithm. So it's going to be log. The base is 4. And you're going to get the product of 2 times 32, which gives you the log base 4 of 64. Now, as you go from 2 logarithms to 1 logarithm, that's called condense. As you go from 1 logarithm to 2 logarithms, that means to expand. So the process can either go in 2 directions. Either you can condense, as we did here, we condensed and made it into 1 logarithm, or you can go in the other direction, which you can expand to 2 logarithms, okay? Now, we're going to go ahead and do the next example. We have log and base 5 of 25 plus a log base 5 of 625. So we look at the 2 logs and we ask ourselves, does it have the same base? And of course the answer is yes. So you're going to write log, make sure you have base 5, and then you're going to multiply 25 times 625. So the log base 5 of the product is going to be the product of 25 times 625, which is 15,625. And remember, as I said before, as you go from 2 logarithms to 1 logarithm, that calls it's condensing, or you want to condense the logarithm. And if you go in the other direction, that means you're trying to expand and make it more than 1 logarithm. So now we have the next example. We have log base 6 of 4, and we have log base 6 of 9. So we do have the same base. So you're going to write log. The base is 6. You're going to get the product of 4 and 9. So we have log. The base is 6. And 4 times 9 is 36. And if you wanted to evaluate this, 6 to what power gives you 36? And you know that it's going to be 2. The next property that I want to review is called the quotient property. Remember that quotient means to divide, and recollect the quotient property for exponents. We know that if they have the same base, then you're subtracting the exponents. In this case, we're talking about logarithms, and you notice that we are subtracting the logarithms here. So that means you can go in the other direction to where you're dividing and you make it into a single log, or you can go in the other direction and expand and make it into more than one log. So what we're going to do is we're going to express the following as a single logarithm. So the first thing you need to ask is, do you have the same base? In this case, you do have the same base, so you're going to write log base 4, and you're going to find the quotient, which you're going to divide 32, you're going to write as a quotient 32 divided by 2. And we're going to go ahead and divide, so we have log base 4, and 32 divided by 2 is 16. So let's go back. Remember, we needed to ask ourselves if it was the same base. In this case, it was the same base. So this process going from two logarithms to one logarithm is called a condense. And then the other direction would mean to expand. If I look at the second problem, or the second expression, we have log base 7 of 49 minus log base 7 of 7, and we do have the same base, so we can go ahead and make it into a single log. So we have log base 7, and we're going to write this as a quotient 49 divided by 7. So we have logarithm base 7, 49 divided by 7 is 7. So if we went from here to here, that means to condense. In the other direction, it would mean to expand. And those are two key words that you need to be aware of. In one direction, it means to condense. In the other direction, it means to expand. Remember that there is a property, log base 7 of 7, that's going to be 1. Okay? The next one, do we have the same base? That's the question. In this case, we have the same base. In this one, we have the same base. These two, we have the same base, so we can go ahead and condense to one logarithm. So you have log base 5, and you have 625 divided by 125. So now you're going to divide, so you have log base 5, 625 divided by 5 is 5, and we know that this logarithm is equal to 1. 5 to the power 1 gives you 5. And the direction, if we go in this direction, that means we're condensing. And if we were to go in the opposite direction, that would mean to expand. Okay? For exponents, when we talk about the power property, we say that a power that's raised to a power is going to have a product. So we have this logarithm that's raised to a power. Well, what you can do with logarithms is you can make it into a product and vice versa. So there's two directions on this also. You can make it into a product, or you can make it also into an exponent. So for example, this one, it says log base 3 of 81 raised to the second power. So there might be instances where we don't want the 2 there, so we can write it as a product 2 times log base 3 and then 81. It all depends on the situation. You may have to have that number or that exponent as a product of the logarithm. So for example, the next one, we have that 3, so we have 3 times the logarithm of 5, and that's also 1 over 5. Now something interesting about 1 over 5, if you wanted to express that as a exponent, 1 over 5, let me tell you what that would be. It would be 5 raised to the negative 1. So once again, that negative 1, we don't want it there. We can make it into a product. So it's going to be negative 1 times 3, which gives you negative 3 logarithm of 5, 5. And we know what the logarithm of 5, 5 is. This itself, this right here, we told you there's a property that's going to be 1. So if we wanted to evaluate this, this eventually would just be negative 3. Okay, so the next one we have a 5. We don't want the 5 there. We want it as a product. So we would say 5 times the log, and we have the base of 4, 64. Okay? The inverse property, you have two instances. You have a situation in which you have log base b of b. And if that's the case, then what's that going to equal to? It's going to equal to the x. The second scenario is you have a b that's raised to a logarithm with the same base, and that will still also be x. So in this example, we have a logarithm base 9 with the same base 9, and it's raised to the power 5 plus x. So this will just simply be equal to 5 plus x. Since the 9s are the base and also the base of this exponent, so it would just be the power. The next one we have log base 3. So we're going to go ahead and we're going to do some manipulation. We know that 3 to the second power is 9. We know that 3 to the third power is 27. And we also know that 3 to the fourth power, we know that 3 to the fourth power is 81. So you see you have a base of 3, you have a base of 3, and I did change it. 81 is equal to 3 to the power 4. So that 4 is ultimately, this expression will equal to 4 because of the inverse property. And I gave you the reason what I did to 81. I converted it to 3 to the power 4. The last one, we have a 7 as a base. And then you notice we have a logarithm of 7. So what this is going to equal to is 90. So that is called the inverse property. There are times that we have to change the base. In other words, the b value has to be changed. I'm going to go ahead and explain to you how to change the base. In this case, we're going to change it to the common base, which is base 10. So we'll change to base 10. So for example, the logarithm of base 9 of 27, and you want to use a calculator, you're just going to go ahead and make it into a quotient. And you see how I'm in base 10 now? And you're gonna write the 27 in the numerator and the 9 in the denominator. We're going to go ahead and we're going to divide log base 10 of 27 divided by log base 10 of 9. That gives you 1.5. So we're going to go ahead and change this to base 10. So we have log base 8 of 16. I want to go to base 10. So you have a logarithm. You have a logarithm. And you're going to write 16. And you're going to write 8. Type that into the calculator. And base 10. It's a repeating decimal, so I'm going to round it off to the nearest tenth. So it's 1.3. The next one we have log base 27 of 81. I'm going to change it to base 10. So we have log of 81 divided by log of 27. So go ahead and use your calculator. And this is also a repeating decimal, so it's going to be 1.3. To summarize, remember we have the product property. Remember that they have to have the same base. And if they have the same base, you can multiply the m and the n and go vice versa. The second is a quotient property, and remember it has to have the same base. And if you're subtracting n, log base b of m minus log base b of n, you can divide. The power property states that if you have a power in the logarithm, you can set it as a product, and then vice versa. The inverse property, if you have the same base, then it's going to be the exponent. If you have the same base here, you have a base that's raised to a logarithm, it's going to be whatever that value x is going to be. And then the last one, the change in base, we have log base b of x. If you want to change it to whatever base, I chose 10. I chose 10 because that is the easiest to do since we have that in the calculator. And all you have to do is divide log of x divided by log of b. It's the same, it's a common base. So now the key word here is to evaluate. In other words, we want to work it out. So we're going to have to use our understanding of properties, and I'm going to work that out. I'm going to work that out with you. So let's make it into a single logarithm. That's our goal. It has the same base. So you have log base 4, and then 2 times 32 is 64. Now here, remember that this is the power. And you got to check. 4 to the second is 16. 4 to the third, I would have to figure that out. Well, we figured out that 4 to the third is 64. So I think we've already evaluated. So the power is going to be 3. 4 to the power 3 gives you 64, and that checks. So we've already evaluated this logarithm. You got to also understand some arithmetic, making sure you understand your powers. So the second one, we're going to use the quotient property. We have the same base, so we have log. So we have log base 7, 49 over 7 since we're subtracting. We have log base 7 of 7. Remember, if these two are the same, we have 7 and 7. It could have been 8 and 8, 9 and 9. It's going to always equal 1. So we've already figured out the solution to the second one. This is called evaluating, okay? The next one, we have a 2. We have a 2 as an exponent. Remember, we said there'd be times where we don't want the 2 there, so I'm going to make this as a product. So you have 2 times the logarithm of 3, and then we have 81. Remember that the logarithm base 3, we can make 81 into base 3. 81 is the same thing as saying 3 to the third. 3 times 3 is 9. 3 times 3 is 9. 9 times 3 is 27. So 3 times 3 is 9, so it's going to be 3 to the 4th. Let me erase that. It's 3 to the 4th because it's going to be 27 times 4. So I'm going to write 3, and then I have 3 to the power 4. Once again, we have that 4 as an exponent. We can make it as a product. So it's 4 times 2, because I'm going to move this in front as a product, times log base 3 of 3. We know that this right here will be 1, and so we just have to multiply 4 times 2, which is just 8. And then the last one, we're going to write a 3 here times the logarithm of 5. And I'm not going to make that into a fraction. What I'm going to say is 5 to the negative 1 power. And since we have a negative 1 here as an exponent, I'm going to use the power property and make it as a product. So it's negative 1 times 3. We have the logarithm of 5 of 5. We know that that's 1, so this is negative 3.